Alright my friends, are you ready for the demo? I remind that this demo works for any dataset, regardless of the number of features, and as long as they have, the features in the first columns and then the dependent variable in the last column, and also assuming that any missing data or categorical data was already taken care of thanks to your data preprocessing toolkit. Alright, so this is going to be very exciting because it's really now that I'm going to show you the power of code templates and how you can quickly and efficiently select the best regression model. Alright, so let's do this. Enough talking. I'm going to proceed to the demo now, just resetting everything because we're going to do something fun. We will actually use this run all option of the runtime, which will run all our cells at once so that we can really optimize the efficiency. But let's not forget to upload the dataset in each of the implementations. Otherwise, this cell won't be able to execute. So we're going to upload it now. It is connecting to runtime, and in a second we should be able to see the upload button. There we go. So let's click this upload button, and now on your machine you're going to find the folder, the model selection folder. That's the whole machinery dataset folder, and that's this new model selection folder containing, that regression folder with all the code templates for regression and the classification with all the code templates for classification. If you missed that folder somehow, don't worry, it was given right before this tutorial, in the article. At the bottom, you had a zip folder attached, which you could download on your machine and which contains exactly the same as what I have here. Alright, so now we're going to go to the regression folder, which contains all the implementations, meaning all the code templates for each of your regression models, both in IPYNB format, which you can open with either Google Colab or Jupyter Notebook, and in PY format, which you can open with a classic Python terminal or Spider in Anaconda. So you have everything, and you also have the dataset, containing these 4 features: the ambient temperature, the vacuum, the ambient pressure, and the humidity, and we predict the energy output. Alright, so that's a very classic data set, once again very generic, trying to represent the other future data sets you'll be working on. And well, speaking of this data set, that's exactly what we have to select here, so we're going to click open to upload the data set in our notebook. And there it is. And now, as I told you, here in the implementation, you only have to enter the name of your data set. And as far as we're concerned here for our demo, well, this data set is called data.csv. Alright, so now we're going to quickly do exactly the same for our other implementations. Upload, then data.csv, then open and loading it, uploading it, and we'll have it in a second. And then we'll just replace the name of the dataset here by data.csv. So that's for polynomial regression. Now for support vector regression, well, same, upload data.csv, open, and loading it, uploading it. And in a second we should have it. There we go. Now we only replace this by data.csv. Then for decision tree regression, there we go, upload, then data.csv, open, and we will have it in a second, uploaded in the notebook. And now replacing this by data.csv. And finally for random forest regression, upload, data.csv, open, and now replacing this by data.csv. And now, my friends, we are finally ready to test each of our regression models and figure out in a flashlight which one is the best. Remember, the closer the R-squared coefficient is to 1, the better is your regression model. So in order to figure out which is going to be the best model, we'll just take the one with the highest R-squared, with the R-squared that is the closest to 1. Alright? Are you ready? Let's do this. Starting with multiple linear regression. So now we're simply going to go to runtime and then run all. And all the cells are now executing. And there you go. We end up with an R-squared coefficient of 0.93. Very good one. As we can clearly see, the predictions are amazing. They're very close to the real results. So remember, this first column is the vector of predictions, and this second one is the vector of real results. And that's why here we have an amazing R-squared coefficient. But according to you, is it going to be the best model? Well, that's what we're going to figure out very quickly, because then we're going to run all the cells here for the polynomial regression. There we go. As you can see, it's going very fast. And well, for the polynomial regression model with, remember, a degree of 4, we get a final R-squared coefficient of 0.9458. So we already beat our multiple linear regression model, and therefore so far the best one is polynomial regression. Feel free to actually test some other degrees if you want. But now we're going to move on to support vector regression and see if it's going to beat the polynomial regression. I actually really like this model, and usually I get the best results with this, but let's see. Let's run all the cells, and in Flashlight we'll get the final performance. No, not yet actually. And by very short, it beats indeed the polynomial regression model, 0.9480, and here we had actually 0.9458. So far, the best model is the support vector regression. Can you see how we're going super fast here, right? We only had to change the name of the dataset here, and all the rest is automatic. And that's the beauty of code templates. Now let's move on to the next one, decision tree regression, and let's see if it can beat the support vector regression, which remember has 0.948. So let's see, let's run, all the cells, and the final result is 0.922. Okay, so that's actually the worst. I think it is indeed worse than the multiple linear regression. Yes, so the decision tree regression model did not perform well here, but maybe that's because it didn't have enough team spirit to tackle these predictions. And that's what we're going to figure out with random forest regression, because indeed a random forest regression model is a bunch of trees teaming up to return an ultimate prediction. So now the ultimate question is, do you think that the final winner of this competition is going to be the support vector regression model or the random forest regression model? Take your bet and let's see if you're right. So there we go. We're about to find out in a second, because we're going to click run all now, and we're going to get the final result with a final R-squared coefficient of actually 0.96, which therefore makes the random forest regression the big winner of this data competition. So congratulations, in a very few seconds you were able to quickly identify and select the best regression model, and mostly, the most important thing in all this is to finally know how to answer this very often asked question, how do I select the best model? And well, the answer is you simply try all of them, and using the R-squared coefficient, you compare them and conclude on which one is the best. And in our situation here, for this data set, well, the best is the random forest regression. All right, so congratulations. Now you know a lot. You have an expertise in regression models. You not only know how to build them, but also you have all these code templates which you can use very efficiently to select the best machine learning model for your regression problem, and that for any data set. And remember, if your data set has missing data or categorical data, well, you only have to grab your tools in the data preprocessing toolkit to handle these situations, and then you can deploy your code template. All right, so I'm super excited and super happy now that we completed 100% this part 2 on regression. And now, my friends, we're going to move on to a brand new branch of machine learning, which is classification, and which we're going to do exactly the same, but this time to predict a category. And same as what we did for this regression branch, well, we will build several classification models, and at the end I'll show you again how to select the best one. So I can't wait to see you in this part 3, and until then, enjoy machine learning.